Hey everybody, welcome to Intro to Java Programming video. In this video, I want to talk about some of the math methods that you're going to need for this week's project. This is going to be kind of your introduction to some of these methods. The math class is a class in Java that has, well, it does all kinds of math stuff, kind of like it sounds like it would. It's got a whole bunch of methods that do calculations that you can't do just with Java operators and would be difficult to write into a program quickly and easily. So given that there are things that are done over and over and over again, somebody who was a developer for Java just wrote that code to perform those operations and put it into a method. Think about some of those that would be a little bit complex to write a program for, like square root or squirt here. In math, at some point, probably in one of your algebra classes in high school or in college, you learned how to estimate a square root. And there's a sort of a repetitive process that you do over and over and over again to narrow down a value to its square root. You could write a program that calculates square root, but it's something that's done a lot in programming. There's a lot of times when you're doing geometry where you're going to have to do square roots. This week's assignment, you're going to have to do a square root. So you don't want to always have to write all that code out that's going to perform the square root operation. So somebody did that for you and they put it into a method. Some of the other ones would be things like POW, and that's for exponentiation. We're raising 2 to the third power, or ABS, which is absolute value. Another thing that you have available to you would be pi, and that's math.pi. All of these methods are called to the math class. These methods are called static methods. I'm not going to go deep into what statics are versus non-statics, but just know when you have a static, you call it to the class name and not to an object reference variable. So these are all being called to the class name: math.pow, math.abs, math.squirt. So let's take a look at how these actually work. So I've got a variable called dResult. Math.pow 2, 3 are the two arguments in the parameter. The first argument is my base. The second argument is my exponent. So I'm taking 2 and I'm raising it to the third power. And what it's going to do is it's going to give us those calculations 2 to the third power, and it's going to return it to this point. A return means that when the method is done executing, it gives us something. So this is going to give us a double result, and it's going to return it to this point. So dResult gets math.pow 2, 3. So 2 to the third is 8.0. It returns it to this point, and it's going to store that right there. Math.abs is absolute value. So absolute value is the absolute distance of a number from 0. So negative 500 is 500 away from 0, so it gives us 500.0 at this point. It returns 500.0 and it stores it in there. Math.squirt is the square root. The argument in here is the number that we want to get the square root of. So 144, the square root is 12, if I recall correctly. And it's going to return 12.0 to this point and store it in this variable. So that's how these math methods work. Now, how do we use these methods in calculations? You can look at this method and treat it just like you would treat a double number. So this whole statement here really is just a representation of the value 8.0. Okay? This really is a representation of the number 500. This really is the representation of the number 12.0. So when you see these things, they have to resolve and they give you a number. So in this case here, the way it's going to work is this has to resolve here before the calculations can happen. So method calls happen before the arithmetic operators happen. Math.pow R2, that means we're going to take 14 and we're going to square it, and it's going to return that value as a double precision float at this point right here. Then we're going to multiply that times math.pi. Okay, so this is going to be a double precision representation of pi. It's up to like 16 digits of precision, if I recall correctly. I can't recall how many digits there are, but there are a lot. So this is a very precise calculation of our area of a circle. We've got pi times r squared. So that's how you'd use these in calculations. Let's really quickly look up how to find the area of a regular pentagon. Area of a regular pentagon. Here is our formula. It is square root of 5 times the quantity 5 plus 2 times the square root of 5, all of that times a squared, and divided by 1/4. Okay, so let's see how this would work as a calculation in Java. I'm going to move this off to the side so I can see both. Give us some more room here. And I'll go double A, and I'll say that is 5.0. And then I'm going to go area gets, now we've got 1/4. And I'm going to put this into parentheses just to make it clear in my statement here what's going on. And then in these parentheses, I've got this whole math.squirt thing right here. Okay, so math.squirt, and it's got to take something in there as well. And inside of there, I've got 5 plus 2 times the square root of 5. So let's take a look at this. This is kind of confusing. We've got a lot going on here and a lot of parentheses. Now, math.squirt is going to give us the square root of this whole thing right here. Okay? That's what's happening there. Now, 5 times 2 times math.squirt 5. So that's the square root of 5 times 2 plus 5. That's this value right here. Okay? And I've got to have this whole thing times 5. So math.squirt times 1/4. Math.squirt 5, that's that 5, times 5 plus 2, that's 5 plus 2, times the square root of 5. And then this whole thing here, this math.squirt, this whole thing here, I think that's it. Yeah, that's got to be times a squared. So math.pow a raised to the 2 power. Let's see if this agrees. Area, and that's my area, is 1/4 times the square root of, so math.squirt, 5 times 5 plus 2 times 5 plus 2 times math.squirt 5, so square root of 5, and then that whole thing times a squared, math.pow a squared. Now, if that's 5, I'm going to output this. And I'm going to check it here. That should be 43. Cross our fingers and let's see if it's actually 43 here. 0.0, well, what's my problem here? Well, 1 over 4. This is the problem. 1 over 4, 1 divided by 4, if these are both integers, by default, these are ints. If I divide 1 by 4, it gives me 0. That's a real problem. So I need to make sure that this is not going to give us a integer result. I want to make it a floating point result. I'll just go 1.0 divided by 4. And there we go, 43.01. It works. So we had a little problem in there, but we found that anytime we do division, we want to make sure that we're doing division with floating point values. Unless there is an absolute need to do your division with integers, always do them with floating point values. So let's review this whole statement here. We've got our 1/4 right here, which is 1.0 divided by 4. We chose 1.0 because it would make this convert to a double type, and it would give us that decimal value we're looking for. It would give us that 0.25 that we're looking for. If we don't do that, it gives us just 0. And then we multiply that times this whole thing, and it gives us 0, and that's a bad result. So 1/4 times the square root of 5 times 5 plus 2 times the square root of 5. And that's right there. And that's multiplied by a squared. So that's how we work with these math methods, and that's how we do these math methods in calculations. You're going to have to use these math methods in calculations in this week's assignment because you're going to be finding the distance between 2 points in a coordinate plane. That's going to require you to use math.pow and math.squirt to do that operation. Thanks for watching.